Alright, so the presentation I decided to do my presentation on is a talk from Defcon20 that Zack Fasel gave on his tool that he created called ZackAttack, which does something called NTLM relaying to basically get you the domain admin on a network. I'll give a little disclaimer here. The OP, or original presenter in this case, talked really fast and about a lot of stuff in just 35 minutes. So this is the dumbed down version that I'm able to convey in you in about 10-12 minutes and explain in this presentation. An overview of what I'm going to talk about. So NTLM relaying is something like passing the hash, but passing the hash requires you to have a domain. You have to have admin privileges on a network. This does not require that. I introduce a new tool set, which is the ZackAttack, that does a cross-protocol relaying. So there's a few different protocols that it actually uses. I'll go over those later. Which also has to do with the methods of getting Windows to auto-authenticate. And then the targets to relay hashes too. So a little bit of a background on NTLM hashes. I know we all know it from class, but they're MD4 encryption, case sensitive, unlimited length, which makes them pretty hard to crack if there's password complexity and long passwords. So the idea here is that you don't have to crack the passwords. You're going to get authenticated on the network without actually cracking the password. There's a few versions of NTLM on Windows machines. The specific one I'm going to talk about in this presentation is NTLM Auth. There's also V1, V2, and NTLM2, and each of these can be signed or not signed. So they have a client-side signature that basically adds another level of security. So NTLM Auth is kind of similar to the TCP handshake. There's 3 messages sent between the client and server. The first one for NTLM is type 1, which would be like your SYN packet. It's basically requesting to start a NTLM authentication. The type 2 would be your SYNAC, or in this case it's a challenge that comes back from the server that gets implemented in the type 3 message that you send back. And the type 3 message that the client sends back is a like your acknowledge, but the hash, the actual NTLM hash, is salted with the challenge that came in message 2, and I'll show you this in the next couple of slides. But like I said, it uses a hash as a credential instead of the plain text password. So this is a typical type 1 message. The message type would be the NTLM SP negotiate, and the flags that are set are what the client actually supports, and it has the option of passing the name of the domain and workstation. This is a typical type 2 message, and this message is the challenge. So this comes from the server and gives the domain, the flags that the server supports, the NTLM challenge, which is what will actually salt the hash, and then at the bottom there's the domain name, the host name, and the DNS name as well. And then this is the NTLM SP auth, which has the NTLM response, which is the actual NTLM hash with the salted hash in there, along with the domain name, the username, and host name of the client. And then that session key is also set up for signing as well, and the flags are at the bottom as well. So Windows has something called integrated auth. So this is when you're connecting to services on a Windows box, and you don't have to keep typing in your password, so you don't have to keep entering it in. It just automatically queries the API and pulls down your credentials. So to execute NTLM relaying, Zack Fasel built this tool that basically builds a HTTP and a SMB server that are rogue. And the idea here is that I compare it to almost like a man-in-the-middle attack, where you get the client to send you that type 1 message. That type 1 message you take and send it off to a server and get the type 2 message back, and then you send that to the client, and the client then authenticates to you, and you then steal that and authenticate to the server. And the trick here is that you need to keep the user authenticating while this is going on. So you take, for the HTTP server, it's fairly simple. You just do a 302 redirect with the keep alive header, so it keeps your session open. And with SMB, Zach mentioned that it was a bit tougher, so he had to build what he called the Alzheimer's feature into the SMB server, a custom payload. So it takes and basically forgets you. It says, hey, I'd like to connect. Cool, I'm glad, let's do it. And then it kind of forgets you. So some of the attack methods, like how you actually get this to work, is the first one that he talks about is WPAD, or Web Proxy Auto Discovery Protocol. So this protocol, if you set up on the SMB server, will check DNS and then broadcast also to the network to try to find host. And if it does, if they're Windows host, it will auto auth using HTTP with the current logged on users' credentials. The limitation is this, that you actually need to be on the network or do something like spoofing DNS. Or the second method he talks about is a few things with social engineering. You can embed a UNC path into an image tag or iframe for IE, so you send them an HTML page link with an embedded UNC path, so it tries to connect to a share, and then Windows will auto auth and you have it. In Chrome and Firefox, they're a bit more difficult because they have the security context, file security context. So his workaround for that was a forced download, which basically creates an entry into the file security context that says, yeah, this share is trusted, and go ahead and download from it. So it downloads. Another vulnerability found is that in Firefox and Chrome they have plugins, so like iTunes and QuickTime, you can create a playlist with a UNC path in it, and then it'll automatically connect, open the share, and authenticate. A couple others, email. So if you have Outlook and email, and HTML email comes in containing a network share, Outlook will automatically open the share and then NTLM will auto authenticate. Then you can embed an image into a .doc file with the UNC path again. And then a couple of the more like not common ones would be the desktop.ini files, which have to do with your folder icons, and you can change the background or the wallpaper to contain a source file, so that would auto auth to the share. So what can you do with this? Depending on which protocol you actually relay, gives you what you can do. With SMB, you can enumerate users and groups, access file shares, execute commands. With LDAP, you can enumerate domain, users, groups, membership, change password, add users to groups, relay domain admin to user workstation, authenticate domain controller. If they have MS SQL, you could potentially access a database and you read, write, pull down from it, get whatever you want, sensitive information. One of the cool ones that he found, the ones I've listed so far, are you're only able to do if you're internal to the network, unless you do something like the DNS spoofing. The Exchange web service will allow you to externally use NTLM relaying, because you can send them an email, and the Exchange will connect with the NTLM auth and get email contacts, set up email rules. You can drop their sent items or their deleted items. So the last thing I'll talk about is how you can kind of mitigate the attack. Firewall outbound connections on port 445. 445 hosts SMB. There's in Windows group policy, you can limit what NTLM auth targets you can actually authenticate to. And then the last one, disable NTLM. If you disable NTLM, it's more secure, because NTLM is pretty easily broken, whether it be cracking it or doing something like this, a different type of attack. But the only problem with that is in a lot of areas out in the real world, there's legacy systems and legacy machines that need to use NTLM. So thanks for listening. Any questions? Well, I guess you can't answer them because this is a video. So if you want to email me, it's wjhofer@pluto.dsu.edu. Thanks.